Hello, this is Ms. DB. In this video, we are going to finish working on the Solving Systems with Algebra worksheet. And in this video, we will be focusing on how to solve systems with elimination. So it's another method of using algebra to solve. Sometimes this one works better, sometimes the other method works better. So we'll practice doing both so that you know how to do both, and then you can choose from here on out which one you want to use. Alright, so here's our steps to use elimination. The first step is you add or subtract the equations to eliminate one variable. This doesn't always work. This only works if it is set up already. So in these first problems, they'll all be set up, and we can start with step one. This example shows you what set up means. So we have here 3x plus 2y equals 7. And then we have 5x minus 2y equals 1. So when I say set up, what I mean is that you have one of the variables has the same number in front of it for both equations, and one's a positive and one's a negative. So we have that right here. We have, get my pen here. My pen has been finicky lately. There we go. We have a plus 2y on the top, and we have a minus 2y on the bottom. So what happens when I add these two equations together is 2y minus 2y is 0. They cancel each other out. So that's what we want for elimination. Sometimes, like you'll see in a little bit, you have to make it look like that first. You have to do a little more work. But in these first few problems, it'll already be set up, and all we'll have to do is add them together. So in this one, when you add 3x plus 5x, you get 8x, and then the 2y minus 2y is 0, so you just get 8x equals 8, and you can solve that really quick, divide both sides by 8 to find your solution. Now that's only part of the solution, of course. Then you have to do the same steps you did before. These are exactly the same as they are for substitution. You have to take what x is equal to, plug it into one of the equations, the original ones, doesn't matter which one, and then you solve and find y. Sometimes that takes considerably more work than the first part of solving for the first variable. Once you find your solution, you should check it. You can either check by plugging both the x and y values into both equations, or you can graph it and see if these two lines did indeed cross at the point 1, 2. So for 6, 7, 8, 9, 10, you can see that these are set up to be able to do these steps right away. They're set up so that you can eliminate one of the variables, 2x minus 2x. Let's see, on this one we have 4y minus 4y. On this one we have plus y minus y. So only on, it's not through 10, it's 6, 7, and 8, they're set up for you. Now when you get to 9 and 10, you have an additional step first before you can go ahead and do that. And the additional step is usually to multiply both sides of one of the equations or both equations so that you can get that plus 6y minus 6y. See, on number 9 right now it's minus 3y. So we can't add these together yet because you would get, if you added these together now, you would get 7x plus 3y equals 80. That doesn't help us because we still have an x and a y. Our goal in solving systems is to get one equation with one variable so that you can find the value of that variable and then go back and find the other one. All right, so let's pick one of these. Number 6 is started for you. They already added, all they did was write the plus sign. So they showed that you're going to add these together, and 2x plus negative 2x is 0. 1y plus minus 3y is negative 2y, or 1y minus 3y. And then we have 1 plus 5 is 6. So you're almost done solving for y already. So you'll finish, you'll find what y is equal to, and then you still have to find out what x is equal to by taking your value of y and plugging it back into one of your equations, and then solve for x. And number 7, it's already set up. You just need to add these together and you'll see that the y terms cancel, so you'll be able to get something x equals something, find out what x is equal to in this case, and then plug that back into one of your equations in order to solve for y. In number 8, same thing. We have 2x plus y equals 12, and then the second equation is negative 5x minus y. If we add these together by just taking the x term plus the x term, the y term plus the y term, and the constant plus the constant, when we add these together, we'll find that 2x plus negative 5x, or you can think about that as 2x minus 5x, is negative 3x. Y minus y cancels. You don't need to write anything. Don't write plus y, just leave it. And that will be equal to 12 minus 33. And that would be negative 21. Negative sign is gone. Once you have that much, then you know that the next step you need to do is solve for x. So you could divide both sides by negative 3, and then you'll know what x is equal to. In this case, x would be equal to 7. And then again, once you know what x is equal to, you still have to find y. So you pick one of your original equations. It doesn't really matter which one. If there's one that looks a little easier, less negatives, then use that one. And then I replace x with that value that I just found, and I finish solving this to find out what y is equal to. So y is equal to something, and then write your answer as a coordinate. It'll be 7, comma, because x was 7, and then put the y value in there. All right, let's look at the ones that are a little bit more work. So we are going to have to solve these for a variable, or I mean, make one of these match the other one. So in number 9, I need to either have both the x values the same, the coefficients in front of the x the same, or the coefficients in front of the y the same. And it is better if one of them is a positive and one of them is a negative. So the easiest way to do number 9 would be to multiply both sides of the second equation by 2. Because if you do that, you'd have 2 times 5x is 10x, 2 times negative 3y would be minus 6y, and then 88 times 2 is 88 times 2. 176. Now I can rewrite the second equation. I'm just going to put it above it. Didn't change anything with that one. Now if I add them together, look what we have here. Plus 6y minus 6y. The y term will eliminate, and you'll just be adding 2x plus 10x, and it'll be equal to whatever negative 8 plus 176 is. So you'll be able to find the value of x quite quickly. Let's look at number 10. We have 5x minus 3y equals 42, and 8x plus 5y equals 28. There's nothing that I can multiply the top one by to make it equal the bottom. 5 times no integer will equal 8. 3 times no integer will equal 5. So I'm going to need to multiply both top and bottom by a number so that I can get the same coefficient in front of the x or the y. Since the y term already has one positive, one negative, I'm going to try to get the y's the same. And I can do that by saying, well, 3 times 5 is 15, so I can multiply everything on the top by 5 and everything on the bottom by 3. Let's see what we get if we do that. The top equation, I have to use the distributive property, would be 25x, 5 times 5x, minus 5 times 3y is 15y, and it equals 42 times 5. On the bottom equation, I have 3 times 8x, that's 24x, plus 3 times 5y, that's plus 15y. So this is looking good because I have minus 15y, and then I have a plus 15y. I was going to move that equal sign from the above problem, but there. Okay, and this is again equal to 28 times 3. 84. All right, now we are ready to add them together. We're ready to do the elimination part because we have minus 15y plus 15y. So they'll cancel out, and I just have to add the 25x plus 24x. And then on the other side, I have to add the 210 plus the 84. And then I can finish solving to find what x is equal to. And remember, once you know what x is equal to, you still need to take that value and plug it back into one of the equations to find y. Let's go ahead and do a little bit more on this one. So we have 294 divided by 49. 6. Okay, x is equal to 6. So we're almost done, but we don't have y yet. So to find y, you're going to go back to one of the original equations. Doesn't matter which one. So look at them for a minute and see if you think there's one that might be simpler than the other. They don't seem like there's really much difference. I'll just use the second one this time. I'm rewriting it. And now I'm going to take what x is equal to, 6, and I'm going to plug it right in where I see an x. And remember, this means multiplication. I'll use parentheses to show that. And now I keep solving until I'm able to figure out what y is equal to. 8 times 6 is 48. Then I would subtract 48 from both sides. 5y is equal to negative 20. Divide both sides by 5 and you'll have your answer. Y is equal to negative 4. So here's my answers, and I'll now write that as a coordinate point, the x value first, comma, then the y value, and there's your solution for this system of equations. I would check it. I'd probably check this one by graphing, and then I would know for sure if that was the right answer after that. You'll always get the right answers if you check them, because if it doesn't check, then you should stop and revise it and see where your mistake was. Number 11, you can solve with either elimination or substitution. I'm going to show you a little trick on number 11. You could solve it for y because it's y is by itself, but you will have a fraction, and some people would rather not work with fractions. So you could also do this. You could multiply both sides of the equation by some number to clear the fractions. So you could multiply by 2, because 1/2 times 2 is 1. Or you can multiply by 4 if you wanted, or any even number will clear the fractions. I'll just go ahead and multiply both sides by 2, which 2 times 1/2, or in other words, 1/2 of 2, is just 1. So I'm just left with 1x. 2 times y would be 2y, and that's equal to 4 times 2 is 8. And look at, what do we have now? We have it set up so that you could use elimination. So you could real quickly solve this by eliminating the variable that has a plus 2y and a minus 2y. Those would cancel if you add it together. Or you could do substitution. You could solve the top equation for x, because 1x is the same as x, and you could then, you'd say that x is equal to 8 minus 2y, and then you could proceed. So there's a couple different ways to do that one. All right, next we're going to do a few word problems. I'll help you with one of them, and then you have to pick at least one more. You could do more for extra credit. For each of them, you do have to write the system of equations and show all your work on how you would solve it. If you just put the answers, it'll be wrong. Your textbook does have examples similar to these kind of problems. So the first one is this field here. It's enclosed by a fence on 3 sides and a wall on the 4th side. The total length of the fence is 320. If the field has a total perimeter of 400, what are the dimensions of the field? So to set this one up, this x would be equal to this x to start with. To find the dimensions, or to write an equation that has to do with the fence, we know it's going to be equal to 320. This piece plus this piece plus this piece will be equal to 320. So we have an x plus a y plus an x. That's one of our equations. However, we could simplify that equation because 1x plus 1x is 2x. So I'll write that a little bit simpler. There is one of my equations. So in a system of equations, you always have at least two. So let's read the question again and see if we can find out what the other one would be. This part. The field has a total perimeter of 400 yards. How do we find the perimeter? Well, that would be x plus y plus x plus y. So it would include the wall. That's the only piece that was missing before. So you're going to write another equation that would be x plus y plus x plus y is equal to the given perimeter, which they said was 400. Well, we could simplify that. 1x plus 1x is 2x. 1y plus 1y is 2y. So you have two equations, and now you can solve those with either elimination or substitution. And here's my two equations. And you will be able to find what x is and what y is, which will be the dimensions of the field. Now, we haven't talked about what to do if you almost have it set up for elimination. We have 2x and we have 2x, but if one of them was a negative, I could just add them together. So all you have to do is multiply the top equation or the bottom of equation, one of them, not both, by a -1. And when you do that, you will have changed it so that one of them is a negative 2x and the other one is a positive still. So I'm going to multiply everything on the top by a -1. And what that then would equal, that looks like -1. I can fix that a little bit. So what do we have? We have -1 times 2x. That's -2x. Then we have -1 times y. That's -y or -1y. Equals, the other side, 320 times -1 would be a -320. So my first equation is now -2x minus 1y is equal to 320. The second equation I don't need to change. 2x plus 2y equals 400. Now they are set up for elimination. I can go ahead and add them together. The x terms will cancel, and you'll be able to solve for y. And don't forget, once you solve for y, you have to go back and find out what x is. And then pick one more of these problems to do. Write a system of equations, which means two equations, and then solve to find out what the answer is. When you do a problem with percents, we are going to change the percents to decimals first. Note that. It says, let's see, a chemistry experiment calls for 1 liter of sulfuric acid at a 15% concentration, but the supply room only stocks sulfuric acid in concentrations of 10 and 35. So they need to know how much of each do we need to add in order to get to this. So one of your equations is going to be, it calls for 1 liter. So you're going to mix the 10% plus the 35%, some amount of each, will need to equal the 1 liter. So that's your first equation. Your second equation is going to deal with those percentages. We need the 10% solution and the, 35% solution. You would change those to decimals, and that's going to equal the 0.15 solution. So use those two equations. Number 2, or the second part of this, would be you would just change this to a 2 in order to get your answer. So here's your here's your system of equations. And if you don't like working with the decimals, you could multiply every one of this second equation by 100. If you multiplied everything by 100, you would get 10x plus 35y equals 15. All right, so you don't have to do that one, though. You might think that maybe number 15 is a little easier, or maybe number 16. So let me know if you have any questions, and have a wonderful day.